we will go ahead and get started. Hey everyone, and welcome on in. Thank you so much for joining us this afternoon for Measuring What Matters using machine learning to analyze recruitment efforts and their impact on enrollment. I am Erin Fields. I am the marketing manager for Enrollify, and I will be your moderator today for the conversation. We are really thrilled to have you here. So, let's talk a little bit about why we're all here today. So, we know that it is hard to draw a straight line between our recruitment efforts and our outcomes that we care about the most, like completed applications or enrolled students. And even when we see numbers go up, it's not always actually clear what moved the needle in your recruitment and your enrollment strategy. So that's where today's conversation comes in. We're going to be exploring how simple machine learning models can help us make a better sense of our data so then we can understand the real impact of all the work that we're doing to reach and support students. And with that, we've got the perfect duo today to walk us through it. First up is Jamie Boggs, and he is a senior engagement analyst here at Element 451. Jamie spent over 15 years serving students directly on campuses before moving into the higher ed tech space. And around here, we call him one of our resident data guys, and for a good reason. His work is really helping institutions across the country turn raw data and real insights to drive change. Joining Jamie today is Timothy Davis, also an engagement analyst here at Element 451. Timothy got his start in digital marketing and web development, and now he uses those skills and that foundation to help schools understand and improve the full student journey from inquiry to enrollment and all the way through graduation. He's got a real knack for turning complex data sets into actionable strategies. And with that, I will hand it over to Jamie and Timothy to walk us through today's agenda.
Thanks, Aaron. I'm kind of having a chuckle at our pictures up on the screen there, JV. We did take those on the same day, and we did coordinate our outfits because we are professional media personalities now, I think. So,
Think so.
yeah, that's what you got to do. I think that was at the Engage Summit a few years ago, and we were all wearing orange, so that was an easy
You were.
coordination. All right, so today, yes, we are going to talk about measuring what matters. We're going to talk about how to do that using machine learning. And that's the primary kind of tool and technology that's going to drive our ability to do that measurement. And so we want to spend some time today talking about what machine learning actually is. It's a term that gets thrown around a lot, just like artificial intelligence, just like large language models. Sometimes it can be kind of confusing what it's actually referring to. And we want to really look at not just what the overarching concept is and what we're trying to do, but actually the inputs and the outputs so that we can have a better grasp of that. And we'll do that across a couple of examples that I'll walk us through. And then Jamie will walk us through a demo to do some of those like real world measurements that we've experimented with at Element 451. And then of course, as always, we've got questions and answers that can happen during the entire presentation, but we'll specifically set aside some time at the end to answer any that you want to talk about. So definitely leave those in the chat, set it to everyone, or send it to hosts and panelists. That would just go to me and Jamie, but I think it'd be beneficial for everyone to see that question for sure. So we'll take some time to do that. All right, let's go ahead and dive into machine learning then, right, Jamie?
Let's get nerdy. Let's go.
Let's get on to it. So machine learning is a bit of a complicated topic, and it can be very complex. And the reason we want to talk about it today is not because you as an admissions professional or a marketing professional or an enrollment management professional need to add this to your tool set. You need to become an expert on machine learning. You need to be able to write the code that you're going to see today or explain the equations that you're going to see today like a mathematician would. But rather for your benefit as you engage with this topic in the world. Machine learning, just like artificial intelligence, is becoming more prevalent. More vendors are offering it. More schools are experimenting with it. And so as you work around your campus and with your partners, you want to know what's going on. So we want to demystify that a little bit and take it out of this abstract world where we typically talk about AI and machine learning into some concrete examples that you can take away with. So give you like a mental model to actually think about this and know what is actually possible. Sometimes we get mixed up talking about, what AI could do, what machine learning can do and is capable of given the right implementation, given the right data, given a sufficient amount of money to pay for it all. But today we're going to see what's actually possible right now. And then finally, we want to see how to use those results. The usability of what you get back from a machine learning model is where the magic is, right? If you do all this work to set up this model and you get some results back, but then you don't use them or they're not actionable, they're not adopted by your operational practices, then what was it all for? What did we waste all that time and headache writing code with, to get through it? So again, this is going to be a pretty technical presentation. We are going to see some equations. We are going to see some code. We're going to see some inputs and some outputs. But I want to start off with just a note of encouragement that you can do this. This is something that you can understand. I think sometimes when we get to mathematics and this is the next slide, Jamie. I want to watch Pikachu. So many gifts. First of many. I think we often write ourselves off to say like, mathematics is not for me. This all computer science stuff is not for me. I don't get it. I gloss over when I see this stuff and when people talk about it. But stick in there, another pass at it today, and you'll start to absorb more and at least come away with some ideas and maybe even some terms that you can use in your day-to-day conversations about this. So don't give up. Stick in there with us. We're excited to have you here. We're gonna have some fun. Okay, so let's start with what machine learning is. I think we could start by saying that machine learning is a machine that recognizes patterns. And we as humans love patterns. We see patterns everywhere. It's one of our like defining traits as humans, as animals. And we see those patterns everywhere. We see them in the weather, right? We love to talk about how the weather changes and we have the seasonal patterns. That's a really easy one. We also see things and patterns of things like behavior. We kind of define ourselves by how we behave, and we define our world by how others behave or how the environment around us behaves. And then another example that I want to spend a second on is language. Language itself is a pattern and is one of the defining traits of being human is the language that we use. And I think that that's an interesting example to sit on for a minute because that's what LLMs, a very, very, very complex version of machine learning, have sort of unlocked is this pattern of language. And now we have LLMs like ChatGPT and Gemini and Claude that can replicate the pattern of language at a scale and at a quality that we've just never seen before that is so human-like. And it's confusing sometimes to see these returns and go, wow, how did you come up with that from just a computer? But again, it's just the pattern. It has seen those, ChatGPT and all of them were trained on lots and lots and lots and lots and lots of language, just like we were growing up. And that's how we adapted the pattern and it's how we learned it. And then over time, adopted grammar, et cetera, to kind of define how it works. But that's effectively what machine learning is, right? Is recognizing that pattern. Another way we can think about machine learning is in terms of an equation. There's our first equation. There's our first math. So first of many, we try to put some math with some gifts to keep it light, to keep us moving and having fun. But that first equation, that first equation there, right, defines the relationship between mass and energy, and its discovery, changed the world in good ways and in bad. But that's that famous equation that defines the relationship between mass and energy, and you can find the mass of an object or the energy of an object based on the other value. There's your input and your output. Machine learning is doing effectively the same thing. That second formula that's below, that is the formula for a standard linear regression, which is the first machine learning measurement technique that we're going to talk about today. So in a linear regression, we have an output and we want to see how it changes based on any number of inputs, right? And so basically that sum there, that big E, it's saying the sum of everything that makes up MI, XI, those are all the inputs. And then we want to calculate B, or we want to predict B based on some set of inputs and their output, right? So that's kind of what we'll look at in a linear regression. So let's look at a silly example that we can sort of have fun with and get us started as we start thinking about this measurement technique. The linear regression example that we'll have fun with today is, can we predict if students will procrastinate doing their homework based on their other activities? So what other activities might we want to consider? We might want to look at the number of coffee cups that they've consumed. We might want to see the number of video game hours they played, parties they've attended, and then obviously maybe like an actual one that might have some validity is their actual GPA, right? So when we build this linear regression, we basically take the sum of all those things and plot it against the outcome. And as we do that, we train on that a little bit and with some known outcomes, and then we can predict unknown outcomes. We'll see a little bit more of that later, but the output from that equation is going to look something like this. That is a plotted linear regression. You see the red line going up through the middle there. That's showing, because all those dots are hanging around that line, that's showing that this is a pretty good linear regression model. And it's been pretty popular to do linear regressions at a high level for universities for a while to kind of predict enrollment forecasting, things like that. What might we see given the recent trend, stuff like that. And this is something that can be done in Excel. It doesn't necessarily require a machine learning model, but it does require machine learning as we scale it up. But our input here is, the sum of all those different things. If they had 30 cups of coffee and their GPA is a 4.0 and their, video game hours are low and their number of parties attended are low or something like that, we'll say that they've accumulated 65 as the sum of all those inputs. And we might then be able to predict that the number of minutes of procrastination is 200, which I don't know. Is that a reasonable amount of procrastination, Jamie?
Yeah, this is something I wouldn't even get to because I would be procrastinating too much to get this analysis done. So,
Right.
this is over my head.
Exactly. Oh man. Well, then with the limitation of just doing linear regressions by hand is you get into situations where what if the number of coffee cups, in this sum here is 63, or something like that. That's so much coffee. Or maybe it's only, maybe it's only 20 or maybe, some arbitrary number. What if that sum, or what if it becomes really dominant in the equation? What if, the number of parties and the hours that you stayed out, is so great that no number of coffee cups is going to correct that and prevent you from procrastinating, prevent you from doing poorly on the test, right? So we might then want to say, what if we decrease the importance of coffee cups in our equation? We don't want to, we want to still consider it, but we don't want it to take precedence over maybe the number of video game hours played or number of parties attended, because its benefit is only so great compared to those other inputs. So then we might do something like this on the next slide, where we take the sum of coffee cups, but we only take like 10% of it. So that's what we're doing there, where we multiply it by 0.1. That's taking 10% of that sum, and that decreases the weight. So we're drawing it back. It could be 150 cups of coffee, but we're still only going to take 15, or count it as 15 effectively. And then we'll compare that or add that in with the number of games and number of parties, and that decreases the importance of coffee cups. Well, how do we decide on that weight? How do we pick how important these things are? Any guesses there, Jamie? How important is coffee in your daily routine?
I was going to say, we call this the Megan equation. Megan Strauss, that works with us, the Element 451 team, lives on coffee. So we really have to account for that in the weight of our variables. So it may be coffee, it may be emails sent, as we'll get to later, that kind of thing. Why don't everybody just comment in the chat and say how much coffee you've had today? I don't want to know about the parties. Keep that to yourself. Let's hear about the coffee.
Yeah, we don't have to get too personal, but yeah, a number of coffee cups. That one a day. That seems like a like reasonable amount. One a day. I can usually get by on one, maybe two. Yeah, two a day. There we go. I had a professor in college though that bragged about drinking like 64 ounces of coffee every day, which seems scary.
May want to check on that first.
Right. You good?
Yeah.
Anyway, so we might want to undervalue or even overvalue a specific variable based on just our intuition. But how do we know if we're making a good guess there? You might want to run that kind of guessing against all the different variables in play. You might want to decrease the value of some or increase the weight of others, see what happens in your outcome. But that can get kind of tedious as you go over and over and over and over again, which brings us to our next measurement technique that we'll look at today, which is a boosted regression. So in this example, we're going to see how many pizza slices will students eat based on the emojis that they use. Again, silly example. We're having fun. That slice of pizza looks really good.
Yeah, pizza's my coffee, I think.
That's like a margarita pizza, right? With like the cherry tomatoes baked on top. All right.
200. Look.
Yeah, let's move on. So in this example, we might measure the types of emojis that are used and how frequently they're used. But the boosting part of that regression is basically the machine taking over that iterative process for you. So it's going to try the crying face emoji at 10% and at 50%. It's going to try the nails at 50%. It's going to try the cowboy hat at 70% and on and on and on like that until it finds the best fit. So it's optimizing it for you effectively, taking away that need to do it all manually. And again, this is where the advantage of using machine learning comes in over just doing it by hand. While you could do it by hand, you're getting a much quicker result um, uh, by using the computer, right? So this next slide has a jump scare. Oh, I was going to count down on it. There's this is a simple visual of a boosted linear regression where it's comparing and finding that best fit. It's doing that in 3 dimensions. But again, just like with a normal linear regression, the boosted regression is going to take in some input of the sum of variables against the best algorithm and output a prediction. So if the sum of all those emojis is 65 or whatever it may be, pizza slices is 8, right? So, okay. I think here it would also be helpful to see an example data set because uh, every machine learning model is going to need to run off of some data set that's usually prepared out of a database or by hand or through Excel, whatever that looks like. And here's an example data set for this pizza prediction model, right? So here we've got some students and their emoji usage. And then you'll see for the first 4 students, we know how many pizza slices they've consumed. That's how we find that relationship between the output and the input initially while the model is being trained, right? So we know for some amount. And once we've trained and validated, then we can predict how many slices of pizza Timothy and Jamie are going to eat. And even without doing that, my intuition tells me it's going to be a lot.
Yeah, it's going to be more than everybody
More than everybody. Talking 15
combined.
slices. Yeah. We're talking Pizza Hut buffet. I haven't
Let's
had
be
breakfast. Oh. Do you still have a Pizza Hut buffet at your Pizza Hut?
We don't. No, ours doesn't even have
RIP.
seat. I don't want to. It's because of me, though. It's my fault. I ran them out of business.
Right. My Pizza Hut still has a buffet. Love that Pizza Hut buffet.
On my
But
way.
yeah, absolutely. So that's an example data set that you might feed to a machine learning example. Of course, very simple. And as you become more and more complex, you can add out more columns, more independent variables, more inputs to consider to try to find the most representative relationship between all those things and make a good prediction. Okay, so the last machine learning measurement technique that we'll look today is the chi-squared. That's a great like mathematic term to drop. Oh man, if you can use that in a meeting and shut the place down, right? Like talking about this analysis is based off uh, a chi-square model. Oh man, that'd be amazing. So for this silly example, we'll look at students' favorite course based on their favorite TV show, right? So here, notice one slight difference. For the first 2, we were predicting numeric values, right? For the chi-square example, we're actually going to prove a statistically significant relationship between 2 categorical variables, right? Because the TV show, that's going to be the name of it. The course, that's going to be the name. Those are categories as opposed to measurements, as opposed to numerical values, right? Which may be integers or decimals. So we're talking about categorical variables in this example. So we might first have a survey where we ask students, what is your favorite course or what degree program are you studying? And then what's your favorite show? So here we'll kind of look at the relationship between marketing, political science, physics, and Star Trek, Mad Men, and Veep. So what we would start by doing is calculating our expected relationship. And the expected relationship, this kind of introduces the idea in statistics and the sciences of the null hypothesis. Our expectation is actually that there is no relationship, that the favorite show and the favorite course are in no way related. They're entirely random, or that we can't measure the relationship in any meaningful way. That's our expectation. Once we have then calculated what we observe the relationship to be, the difference there is our chi-square, right? So, Jamie just dropped something in the chat. I'm going to read that too.
I'm answering a LinkedIn question that came in. Is there a time
Purposes.
when you would tap the total number instead of adjusting the weight. The models we're going to look at today primarily will account for that generally. Like Timothy was showing us what needs to be done. The machine learning models in large part will account for that. If you cap one feature and not the others, that really kind of takes the balance off, and it can throw off those coefficients that are going to help you to calculate things moving forward, and especially those predictions. So I would not recommend capping. I would take it out completely and see what you get first. But if you're going to cap it, you probably should cap everything, and that gets really tricky.
Hmm. That's a great tip. And that's for when you're actually building this yourself, right? If
Yeah.
you're working with a third party or you're working with a managed service, you might not have that ability to begin with. It might be more what
Yep.
data that but you can even provide is the main priority for some admissions offices. But yeah, that's great. That's a great tip. Okay, so finishing up this chart, for example, before I formally hand it over to Jamie to see our demo, this is the result effectively. And that 15.2, that's showing the difference. But what we really care about here is that P value. And that's the lower the P value, the more statistically significant the relationship. So here at 0.004, that is statistically significant. So our inputs here are all those different categorical variables, right? The favorite show, the favorite course, but our output is then the ability to say with confidence, with data backing us up, that there is or is not a statistically significant relationship between, say, VEEP and political science, right? So again, those are the various measurement techniques that we'll look at today. We're going to see some real world examples now. You've seen some of the inputs, some of the outputs, so keep that in mind. We'll try to reinforce those concepts as we encounter them again in the demo. But that's what we're going to be looking at today. Again, ask any questions about those if you want. But now let's actually hop over and see a little bit of code, get under the hood.
Yeah. I was going to say I'm doing real world examples, but I think the examples of study time and coffee consumption, eating pizza and binging TV is probably more applicable when we're talking about college students.
Hey, it might be.
Regardless, what I'm going to focus on for our demos today is actual real life data that we've taken out of Element 451. And this is communication and engagement data that has come from staff members at the schools that utilize our software. So these are going to be actions that are initiated by the school, not by the student, because we want to measure what our activities are doing. What are we doing right? What can we do more of? So what are we doing? And we're going to break this down in a couple different ways. We're going to look at it at the user level. So for every email a specific student got, for every time they were asked to come to an event, what was their outcome? Was it enrollment or was it not? And then we're going to look at it at the school level. And those are going to be the same data sets, except we're going to look at it aggregated by school and see if we can get results that way. And then we'll compare and see how alike or different those are going to be. So we're going to hop into some specific tools. Tag Timothy is in chat now. Going to be answering those questions for you. We're going to start in Snowflake. Snowflake is our data warehouse here at Element 451. And this, I'm not going to go over every line of code. I don't want to lose people that way, but I will kind of just point to where things are as we go along. So this is the model that we're building that's going to be at the user level. So we have this element ID that could be tied back to an individual if we're trying to predict, but doesn't give away any PII, which is great. We have communication metrics like emails that are sent and delivered. Are we sending emails that are bounced? Are we sending texts that don't go through? Appointment schedule, which is one of the newer features in Element 451. That's something we added a few months ago, and that's going to be important to know as well in context. Tasks that are assigned to staff members. So to a specific student. So if a task is assigned for a staff member to follow up with a student in a specific way, we want to count that. More communication, metrics, conversations, and phone calls. And these are all conversations that were initiated by the staff member. So this doesn't count times when students on the website and they send in web chat or they text in or email in first. These are initiated by the staff member because we want to know what we're doing, right? And then events hosted that we've invited the specific users to in that data set, and then events hosted overall in the school data set. And the last one we added just yesterday as we were talking over this is it says owner, but has this individual user, the student, been assigned a staff member? So are we actively assigning someone to monitor the student's application, to kind of be their point person? Because I think that's important to look at for um, just how the relationship piece of how people are associated within the LMIT 451 system. Timothy, before I show the code, do you want to add anything to why we chose this or where those things come from?
Yeah, are you going to run that result really quick?
Oh yeah, I'll show the result. Do you want me to?
Yeah, if you want to go ahead and run that, I was going to pepper in a little bit more information about Snowflake specifically.
Okay.
Snowflake is a database. You probably have a database on your campus, or the vendors that you're working with have some sort of database. We use Snowflake specifically for analytics purposes and allows us to write SQL, which is the database language that allows us to create the various row and column tables that we use to do any number of analysis. Um, but this process is kind of platform agnostic. We're just happen to be working in Snowflake because that's what we have access to. But these processes can be completed in a variety of different ways. But the code you're seeing right now is SQL.
Yep. And I just scrolled through all of it, and we have all these data points and different data sets and tables and views throughout Snowflake. So that was me just pulling everything together. And here I'm assigning it to the student. And again, these are staff initiated activities, and these are activities that I filtered down that happened within a term leading up to either an enrollment or the start date for an intended term coming and passing. So either they did enroll, or they didn't enroll, but this is to a specific student. And you notice I summed all of the activities except for owned and enroll. For owned, I really just want to know if they have somebody assigned to them or not. And for enroll, that's a yes or no. So the binary piece is what's going to allow us to run this regression I'm about to show you. And this is what the data set looks like. So we get it back and it comes back. It's got almost 1 million rows, which is a good solid data set to work with. Again, it's something to keep in mind. The more iterations you have, the more patterns that the model can look at in order to establish those patterns. We can go through each category that we just laid out. You can see these are student identifiers, numbers of communications that they received. This person's gotten a lot of texts that they actually didn't get, was sent a lot of texts that they didn't get. So something like that could tell us, what are we doing wrong that our texts aren't going through? Anyway, we'll get more to the application later. If I get through here, it's important to look over your data. So for example, I don't see any data in these 3 columns. Here, I'm able to just click in and I can see that, yes, there is data that's spread out amongst a number of different options. So that's actually good. It's just not filtered at the top. And the same is going to go for these. So I have data in every column. My owner column is binary. My enrollment column is binary. Another piece I like to look at to make sure that I'm just prepared for what it could do to the outcomes is what is the allocation for students that are enrolled versus not? Because if I have 90% of students in this data set that didn't enroll and 10 that did, that's going to give me a certain type of information to say, I'm probably more likely to find out who's not going to than is going to. This is pretty even, honestly. And this just happened this way. It was not we didn't build it for this, but about 53% of those rows in the data set are students that did enroll. And then a little less than that did not enroll. So the data set actually turned out pretty well for what we want to do. And again, we have almost 1 million rows. In the first model we're going to show is a boosted regression model like Timothy talked about. So this is going to use so many patterns, and it's going to use random forest, I think is specifically what this is built into Snowflake, what they use in their regression models. That does require a binary outcome. So that's why my target column name is the enrolled outcome, which again will be important here in a few minutes. But excuse me, this allows me to train the data set right here in Snowflake that I just created in the other tab. And this is going to go through. So it divides up itself a certain percentage of the data to train on, and then it saves the rest of the data to run tests on to see how well the training went. And that's going to be able to tell us how solid of a model this is and how seriously we can take the results. So I've
You know, I
already,
think,
because I don't do anything live anymore. I've learned my lesson. Go ahead, Timothy.
oh, I was going to say, well, make a point of the reason that machine learning specifically, but also LLMs have become more usable, more accessible is because of services like this. So Snowflake effectively for Element 451 is a service provider for us. And so as opposed to having to go basically write this machine learning algorithm ourselves, which would require, infinitely more work on our part to configure correctly, to make sure that it was all functioning properly at the start, but also to make sure the calculations were correct, we can use this service within our database environment that allows us to just throw our input in and also maybe provide some configuration and then get the result back.
Yeah. Yeah. So this was actually one of those examples. I worked for months building a predictive script, and then Snowflake released this, and I was just like, what are we even doing here? But this is a super helpful use case. And you could go one step further and use this model to predict enrollment of future students, like we talked about with the pizza. We don't know whether these students are going to enroll. Let's use this model to figure that out. That's a different webinar. Not doing that today. But I do want to look at the information we get back from the model to tell us whether we can trust it or not. So first, we're going to look at a confusion matrix, which for the life of me, I can't understand why a table that's meant to make information so clear is called a confusion matrix, but that's the world we live in. What this table is telling us for values that are actual zeros, how many were predicted to be zero, and it was a pretty big number. So the rows 1 and 4 were correct prediction, correctly predicting 0, correctly predicting 1, incorrectly predicting 1, incorrectly predicting 0. So this was the test set that it used after training. So that's why the numbers are smaller. And I like that the numbers of correct guesses are better than the numbers of incorrect guesses, but it's not overwhelming enough to make me sleep good at night. So I'm going to keep digging in here to see the metrics I'm giving back and the results in what they tell me. So the evaluation metrics used for this particular boosted regression come back in this form. There are 3 classifications that we're looking at here, and they're applied to all the zeros and applied to all the ones separately. Okay, this is all thumbs or fingers, but not all fingers or thumbs description of these. Precision is the number of predicted zeros that were actually 0. So that was 73%. Recall is out of all the zeros, how many did our model pick? And that's 68%. And if you read that quickly, that sounds like the same thing, but it's not. So 2 different ways to measure the accuracy of the model. F1 is a harmonic mean between these two, and it's just meant to balance them out if there are large numbers of quantities of ones or zeros. Okay. So we have that for 0.
Let me take us back
for
to
1. Yeah.
to just ground us where we're at. I know we've seen some really sophisticated looking numbers that might be scary. Hang in there. All we're doing is, if you remember back to the pizza table where we knew how many pizzas everybody had eaten based on how many emojis they'd used, we're doing this. We're validating that here. So when we train the model, it has to know the outcome. When the model is then used to make predictions, it doesn't know the outcome. So all we're doing here is we're in the model training step where it knows the outcomes, and we're figuring out how well it got at predicting the outcomes, how fit the line was, or the dots were around the line, how good this model actually is, and if we can even use it. And the decision whether or not you can even use it is, again, a very specialized decision. We're walking you through this again so that you see what it actually looks like. That when people say, hey, we're building a machine learning model, you have a frame of reference to know what it is they're actually doing. It's not magic. It's just SQL statements that return these really confusing looking tables. And
yeah, absolutely. And this, if you do this more than once, this will make more sense. And there are even more precise ways to, you don't have to look at all these numbers. I'm just trying to explain. And when I see these numbers, what I see is the faces of people who have taught me and trained me, and their faces, if I came to them with a precision score of 74%. Generally between 70 and 80 is an acceptable range. So I could probably do an analysis with this. For zeros, it's around 70. For ones, it's around 76, but I'm not going to feel great about it. So I'm going to dig just a little bit more here, and then we'll get to the meat and potatoes of why you're here. Global evaluation does two things. One, it adds this metric of AUC. That stands for area under the curve. And in my experience, this has become a number that I feel like I can trust. This comes specifically from regression models, and it is an accuracy percentage that weights everything. And I've learned to trust it. And this is at 80. So I feel awesome about that. The difference between macro and weighted is that macro average types don't take into account whether there are more ones or zeros, and the weighted ones do. Because ours are pretty much even in this data set, we see actually exactly the same result for AUC. Again, not something we planned, but it worked. So the area under the curve is 80%. I feel like I can take a breath and say, this is the model I can trust. Now, what can I learn from it? The features are the coffee you're eating or drinking, the shows you're watching, the emojis you're sending. So which of those actually matter from that list we showed earlier? And this is where we get the usable information. So this table is ranking the impact of each of the activities I showed earlier on enrollment, on that one or that zero. So this is the situation where you could take these coefficients, put them in a formula. So the number of emails delivered times 0.27 plus the number of SMS delivered times 0.206. And you can get to a prediction for a record within 80% accuracy, going back to that area under the curve.
And that's the weights. So that's
Yes.
the importance of this or that, and how
Yes.
important the equation should treat it. So when we say coffee times 0.1, that's how important coffee is. This is saying, what's the top one there?
Email delivered. Yeah.
Email delivered at
0.27. And these would add up to 1 to get you to that final result. Old people like myself may be trying to tell you that email's dead and people don't read them. The numbers say otherwise. Email is, and these are emails that are delivered. Bouncing obviously causes some negative effects. And you can look at the other pieces here. I want to make note that if we just ran this for your institution, then it may look completely different. This is just with all our aggregate data with schools of every shape and size to illustrate a point. I do think this is useful data because the metrics told me so. But when you look here, you can see that it may not match your institution. And appointments and phone calls at the bottom, those are the two newer features. Not surprised at all. It always helps when these things make sense. All right.
So there's the kind of analysis work there of pairing the mathematical results that you get with what you know about the problem you're trying to solve, right? So you know your school really well. If somebody comes back to you and says, email is really important, or texting is really important, or appointments aren't important at all, you can say, or have a sense of confidence in knowing that maybe appointments are really important, but for whatever reason, the data that they're analyzing doesn't have enough appointments in it. So you can kind of check that against your own knowledge and your own intuition.
And the ownership piece, the students being assigned, some schools don't use that at all. So I think that's an important piece to say. It may or may not work. So the school data can't use the same analysis for the school data because the school data is aggregated. So how many enrollments does that school have? So we had to run a different kind of analysis for that. Here are the results it gave back. This is a logistical analysis that it's written in Python. This tool is Hex. It allows you to write Python and SQL. That's why I like it. The good thing about this analysis is that it assigns negative weights. So if things count against enrollment, then that's helpful to know. But you may see that all of these results are very different from what we saw at the user level. And the accuracy of this model isn't very good. So I would say I can't trust this model right now, but I want to double check the data set. So that's where I run the chi-square analysis Timothy talked about earlier. When I get that back, I get a completely different set of coefficients to show the strength of relation. to the outcome. And then I get the p values, which are all so high. So looking at this and seeing that the p values are really high, there's no accuracy on this model. I would say, as an experienced data analyst, that this data set is not a good one to use for analysis. And that could be for a number of reasons. This only has 178 rows. Remember, the other one had almost a million. So it's a limited data set. You can add more features, take away more features. So the school data set, I don't think is really impressive. One last thing I want to show is I ran the chi-square analysis on the user data to see how that measured up with the boosted regression. So what I have here is the ranking of them by p-value, not necessarily by impact. And look, the p-values on all these are well below 0.05. So this is telling me that while you can never say definite causation, the correlation between these factors and the outcome of enrollment is really, really strong. And that's very helpful to see.
There is a statistically significant relationship, just like between political science and Veep. There's a statistically significant relationship between some of the variables here.
Yep. So my two models for users, I look at the ranks for each of those. Email delivered was first on both. SMS delivered second on both. I'm going to skip this one for now. Conversations fourth on both. Just a lot of consistency in these models. SMS undeliver, obviously very different. And that's really the only one of these that is. That's something you could dig into further to see why that may be the case, but that's the anomaly between the two models. Otherwise, both models have proven to be accurate and have given me very similar results. So for here, I'm using this to either make predictions on future students or make informed decisions about how we're contacting students. Do we need to send more SMSs? Maybe we're not utilizing that. Apparently we're just sending emails. Let's do more of this. Let's initiate more conversations, make sure we're assigning individuals to those records. And again, maybe appointments is something that you haven't utilized. Like given in 2 years, I bet appointments is going to be up here, but that data is not here yet. And those are all things you need to take into account when looking at the actual results on your campus. This will be very different, that this is the way that you can show statistically, this is what we do that works. Now we make decisions based on that. Those are decisions I don't have to make. That's your job, which I'm very thankful for, but we can help you get the tools to get there to where those decisions are easier and backed up by data.
Absolutely. So why do we,
Timothy got to talk about pizza and TV.
I know, man.
I got the p values and precision scores.
Yeah. We said it was going to be technical. So if you've hung with us through it this far, thank you so much. Congrats to you for making it through a really meaty data analysis session with Jamie tonight. That's what it looks like, right? That is the work there. So maybe we could talk a little bit as we wait for some questions to come in, if you do have questions. And this might be the area where questions arise, but if you do have questions, we can maybe talk about how to use this information. So when working with maybe your institution and folks on campus, or maybe with a partner who's doing some sort of machine learning model for you, you could get some results back from a machine learning model. You know, a really common one that we've seen a lot is, can we predict enrollment? Yes or no? The result that you get back from that is a prediction per student. So if you're in maybe a CRM, every student is going to have some prediction based on their run through the model. You also might, if you're so lucky, get back the different types of results that Jamie showed today, that showed the relationship between different variables, that showed the p-score, that showed the feature importance. And in those situations, you can understand the quality of the model that you're working with, because that is also a really big consideration. But the one takeaway that I had from seeing what you were showing there is that, like, yeah, that can get overwhelming. That is a very specialized skill set. If you ever encounter a result like that in the wild, I think ChatGPT or another LLM is a great use case for that. Throw a PDF of that or copy and paste it into a prompt and say, this is what I'm working with. This is some context about it. How do I analyze this data and make decisions? Give me 15 options, 15 decisions I could make. Boom, there you go. Now you're off to the races and you don't have to necessarily come as prepared as you need it to be when, or you don't have to have the degree in it necessarily to start actually using the results you get.
I was exploring that earlier today and taking the actual data set and dropping it in and asking an LLM to look at it. And then how should I explain this to my boss and how we can make it actionable? So
There you
prompt
go.
engineering is going to be really important here, but not only can it help you understand what you're looking at, it can help you understand how to explain it to others and how to frame it in a way that's useful and not just say, look at my p values. Don't do that.
Exactly. Exactly.
Well, thank you, Jamie and Tim, for today's webinar. If you really liked today's webinar and you're like, wow, I can't get enough of these guys and their data, they have their own podcast that you can subscribe to on the Enrollify network. So please make sure that you check that out and catch up on any episodes that you might have missed. It's a fantastic duo that I can't recommend enough if you're interested in data and improving actually what your school is doing, because we all know that you can feel in your gut that something works, but it's another thing to go and prove it. So, slide, please, Jamie.
Oh, sorry.
No, that's okay.
I was having a great time typing in chat. There you go.
And if you're interested in some other places of where Enrollify will be or other things that are going on, Enrollify will be live podcasting from the ASU GSV Summit. So if you are heading to that event in San Diego next month, please be sure to check us out in the podcast zone. On April 30th, Element 451 will be hosting a Work Smarter, Not Harder webinar demo, which will be going over how AI agents and AI teammates can transform campus operations at your institution. And then also, if you haven't checked it out yet, please join us in June on June 24th and 25th for our annual Engage Summit, which will be in Charlotte this year. If you've been with us before, it's been in Raleigh in previous years. But we have outgrown Raleigh, so we are now moving to the Queen City of Charlotte. So if you're interested in that and want to learn more about how to use AI at your campus and actually use it, not just theoretically think about it, please join us and check that out as well. I believe Shelby will be putting the links on the chat. Now, we do have a few questions here to wrap up. The first would be, so once you identify what exactly is working from the data set that you presented, how do you act on those insights and operationally to maybe higher up leaders, or how do you present that information to them?
Yeah, I think depending on where your seat is, I think the presentation is the data says these things are most important. This is how we're currently doing that. Do we need to do more or less? Or we see that this is important, but we're not having success with it. So how do we need to alter those things? It's basically backing it up with data and giving you thought about the actual details. The data tells you where to go hunting, where to go looking in your practices to see what's good, what do we need to do more of. And most of these activities that we shared here can be automated through Element 451, CRM, and can really just flow on their own, and you can increase your touch points that way. Timothy, you want to add anything to
Yeah,
that?
this would be really this might be really useful if you want to prove the validity of some new endeavor that you've undertaken. So maybe, like we mentioned appointments, we want to offer appointment signups online and self-service, and we want to allow students to directly schedule with staff members. Okay, that's a new idea that's, potentially very user-friendly to the student. Might be a little bit extra lift on the staff though. They've got to have some availability. They've got to be ready for meetings that might pop up. How do we know if that's successful? Well, if the machine learning model comes back and says the fact that they scheduled an appointment or attended multiple appointments, attended an appointment with a specific staff, attended a specific type of appointment, and that was a strong predictor of enrollment, then you can come back and say, "Hey, this is working. We have a correlation here with enrollment. Maybe we need to flesh out this service a little bit more."
Or you can take a data set of best practices of multiple institutions and say, look, other people are doing Bolt agents and they're using this to engage with students and to build campaigns. We need to spend more money on this. And the data says it, not me. So blaming everything on numbers is really how I get through life. And I highly encourage you to do the same.
Great answers. And we have one last question here before we wrap up today. What are, if any, privacy concerns involved in analyzing student data this way? I know that's a big hot topic for a lot of people out in institutions and getting things like this approved.
Absolutely. I mean, here in this analysis that you saw today, we didn't use any personally identifiable information. We didn't use demographic information. We didn't use address, phone number, IP addresses. We didn't use anything related to being able to identify a person across the internet. All we did was we have a unique identifier for them. And then I think one of our strengths at Element is that we have so much activity based data. So that's the number of emails they got and how many they opened, the number of SMS messages they got, the number of appointments they've attended. Those are all activities that don't have any PII related to them. They simply tie back to the student's record. And so when we also when we analyze activities, we can kind of neutralize some like biases that are inherent with zip code, that are inherent with race and ethnicity, that are inherent with some family income, right? And we can just look at what's actually happened and what actions are actually being taken rather than what other people in a similar demographic cohort have done. There's my
And
answer.
and even if, let's say, your IDs on campus, since they tie to a person, you don't want to use that. You can easily randomly generate ID codes for each user and then tie that back later in a way that nobody has any way to tie it back besides you. And that's really helpful. When you do use demographic data, if you have that completely unique random code, and then you're using ones and zeros for in-state, out-of-state, and it's directory information, generally that falls within FERPA. As long as you're not digging too deep into, like, I don't know if I go zip codes, that feels a little odd, but in-state, out-of-state, graduate of high school, GED, like those things like that are generally accepted in the greater practice of data sharing without
Yeah.
violate FERPA or other PII regulations.
It also comes down to like who's handling the data, where the computers are located. There's a lot of different factors that go into that. Artist and JC actually have a great episode on Generation AI, their podcast about FERPA and just kind of a breakdown of it. And that I think they've got a pretty good intro to the topic from this perspective.
Yeah, that's a good question, though. It's very important.
Hmm. Actually, sorry, I lied because we had a few questions going on LinkedIn. So we're going to take
Great.
one a little bit from Jordan and David. So Jordan says, can you speak to the challenges of integrating machine learning models with existing CRMs or SIS systems in higher ed?
Yeah, I think it's going to depend on who's doing the machine learning. If it's a dedicated service provider that only does that, what typically is going to happen in that situation is you're going to have to export some data for them to use, and then they're going to export some data for you to use, and that's going to happen across like CSV files or Excel sheets, stuff like that. So that could present a challenge if you're not equipped to be able to generate such a data set. They might have very specific requirements of how that Excel sheet needs to be formatted. We need to have these columns. We need to have this result. It needs to have, X number of rows, whatever. So that can get a little bit complicated for folks that are just doing that specifically. But we've seen a lot of folks or a lot of service providers start to introduce these features. We've talked about how they're a little bit more integrated into Element. I know that there's some other service providers in the CRM and SIS space that are also looking into this in a variety of different ways. And so in those situations, it's less about how you format the data and more about how much data you have in that particular system. So for Element, like one of the challenges that we often run into is that we don't own enrollment records. Right. That's the SIS. That's the student information system. We are just the CRM. We take everybody through application and through the decision up to admitted or conditional offer or denied. But then we kind of have a handoff in there, and it's up really to the partner how they want to configure that handoff. They might just send the student information over to the SIS and the SIS never responds. They say, thank you, have a nice day. Or they might write back that the student enrolled in the institution or even for specific courses, back to Element so Element can have that information as well. And that can be um, a big defining factor of how good a particular model is how much data is available in the system that's using it. I think that I hope that was the right answer. The I don't know, Jamie, do you have a different take on that question?
No, no, I think you addressed the question. The other major challenge that I see is just combining the data from SIS and CRM, making sure there are ways to tie it to a particular student, a particular term. So taking data sets that are repeating rows of different types of data is tricky to weave together. So that's a challenge, but the majority of the time there's a way to do it. It's just a matter of measuring it.
All right, so we are at time, so we are going to wrap it up. I know, David, you have a question on LinkedIn, but we will directly reply to you because we are at 3 p.m. Eastern.
Yep.
So thank you, everyone, so much for joining us. This will be a monthly webinar series moving forward. So please look out for promotions for our next EduData webinar in April. So thank you, everyone, and have a fantastic day.
Thanks,
Have a good day,
everybody.
everybody.
Bye.